Hi, in this short video, I'm going to show you how to use Mathematica to find Laplace transform of a function. You can go to your Wolfram Cloud account and start a new file, and you can call it Laplace transform. Since I'm not using that, I'm using Mathematica on my computer. I'm not going to do that, but you can definitely go into Wolfram Cloud, sign in, and then create a new file, start a new file and call it Laplace transform. Once you're done with that, to find the Laplace transform of a function, all you have to do is type in Laplace. It's capital L, capital T, one word, and then square bracket. Then you type in the function whose Laplace transform you want to find, comma, the variable of that function, comma, and the variable of the transform function, which is going to be s. If you recall, Laplace transform takes a t function and gives you an s function. The transform function has the variable s, and the original function has variable t. Now that's not all, is not always required, but that's usually the norm. Okay, so I'm going to stick with that. So this is the command to take Laplace transform of a function in Mathematica. Now, when you do your homework problems from section 7.2 and 7.3, I expect you to do them by hand. You can use Mathematica to check your answers, but please do all your problems by hand. Okay. So let's quickly do a couple examples. If I want to take Laplace transform, of one of the problems I did in the video, which was t squared minus e raised to t space sine of 2t. Come down. Sine of 2t. Okay, so remember sine is capital S, square brackets for Mathematica function, and then you put a comma. Your independent variable is t, and your output variable for your transform function is s. And close the square bracket, shift enter, you'll get the answer. That's all it takes. Let me do a couple more problems. Let's say you want to take Laplace transform of cosine squared. Remember, when you add, we don't enter cosine squared like this. Okay, that's how it looks when we see it, when we write it. But in Mathematica, you put the square at the end after the function closes the square bracket, comma t, comma s, close it, and that'll give you Laplace transform of that. If you want to take Laplace transform of one of the other examples I did in the video, sine of 2t space sine of 5t, remember to put a space for multiplication, comma t, comma s, close the square bracket, and you'll get that. Okay, so that's how we do Laplace transforms in Mathematica. And one last example. You can also do, let's say, you go escape EE caret negative t, so I'll put parentheses negative t. I don't need those parentheses, it's an exponent. And then I have sine of t. This is another example I did in the video. So if you can do that, then we'll get that answer. Mathematica sometimes combines the Laplace transforms and sometimes it won't. Like in this case, it didn't combine them, but in all these last three cases, it did combine them. Let me do one last example, something I didn't do in the video, just to show you. Let's say you want to find the Laplace transform of t plus 2 cubed. Normally by hand, the way you would do it is you would expand this and then do term by term. So we can close that and do that, and that's what you'll get. So that's how easy it is to take Laplace transforms of functions in Mathematica. As we go through this chapter, I will try to create short videos in Mathematica on how to do those things that we learn in the chapter, because you can use those skills in Mathematica to verify your answers. Okay, so that is my goal, so that way you can verify your work as you do them by hand and use Mathematica to check everything.